this video, we will learn how we can create a chatbot to chat with multiple PDF files using the power of LangChain and Google PaLM 2 model. Let's look at the demo first, and then we will move towards the architecture, and then we will write down the code as well. So first of all, you can see the Streamlit app over here. So I will just click on Browse Files, and over here, I will just upload 2 PDF files. Over here, you can upload 3 PDF files or tens of PDF files as well. It will work for all cases as well. So I'm just uploading 2 PDF files. You have the option to upload 3, 5, 10, 20 PDF files because it can deal with multiple PDF files as well. Then I will just click on process. So in the process part, it will extract the data from those PDF files, split the data into small chunks, and then create a knowledge base. So the processing is currently in progress. So this will take around a few seconds, like 10 to 15 seconds more before it gets completed. The processing is done. I have uploaded 2 PDF files. One is the sample resume, an AI-generated resume, and the other is YOLO V7 object detection model official paper. So I will just ask first question, YOLO V7 is used for. The answer of this question lies within this PDF file, YOLO V7 paper. So let's see if our model is able to generate the response from this PDF file or not. So I am, as a human, I have asked YOLO V7 is used for. The bot response is object detection. Okay. So YOLO V7 is trained on which data set? So now you can see I'm just asking a second question. YOLO V7 is trained on which data set? So YOLO V7 is trained on which data set? Or YOLO V7 is being trained on the COCO data set. That is correct as well. Okay. So I can ask other question from the resume. Rachel Green qualification. So I'm just asking what is the qualification of Rachel Green. So Rachel Green is PhD in English. You can see also the chat history over here as well. So that's amazing. Rachel Green experience. So Rachel Green has experience in managing editors, poetry staff, editorial assistant, graduate mentor, and composition instructor. And now I can just ask question from the other PDF. YOLO V7 outperforms which models? So this is the other question which I have asked. So YOLO V7 outperforms which models? So this is the bot response. YOLO V7 outperforms the following models. And you can see that the list of the model on which YOLO V7 outperforms. So in this way, you can just upload multiple PDF files in this Streamlit application, and then you can chat with those PDF files as well. So that's look amazing. So let's look at the architecture, and let's discuss the architecture of this Streamlit application. So here you can see the architecture of the Streamlit application. So here we are just creating a chatbot to chat with multiple PDF files using the power of Google PaLM 2 and then LangChain. Okay, so over here, in the first step number 1, the user will upload the PDF file, which you can see over here. This is the step number 1, the user uploads the PDF file. In the next step number 2, we extract the data from those PDF files. So over here, I'm using Google PaLM 2 model. The Google PaLM 2 model has an input token limit of 8096 token. So which one token is equal to 4 English characters. So the input character limit or character limit of Google PaLM 2 model is 32,000 English characters. You cannot pass more than 32,000 English characters at the input of Google PaLM 2 model. So when we extract the data from multiple PDF files like 5, 6, 7, 10 PDF files, so as there are a huge number of PDF files, so it can be a case like whether we can have more than 32,000 English characters from the extracted PDF, from when we extract data from the PDF files, we can have more than 32,000 English characters because the user can upload tens of PDF files, and when we extract the data from those PDF files, we can have more than 32,000 English characters at the input. While our Google PaLM 2 model can only accept 32,000 English characters at the input, and we can have more than 32,000 English characters at the input. Okay, so as we have extracted data from the multiple PDF files, so we cannot pass that data directly to the Google PaLM 2 model. So what we do is we split the data into small number of chunks, and we can say that in each chunk we can have maximum number of 500 English characters. So we split the data into multiple small chunks. Then we create embeddings for each of the text chunk. Okay, so embeddings are base vectors. Okay, embeddings are used to compress the size of the text chunk. So embeddings are simply vectors, and embeddings are basically used to compress the size of the text chunk. So if we have 100 text chunk, then we will have 100 embeddings. So we will create embeddings for each of the text chunk, and embeddings are basically vectors, and this is the form of embeddings we have. Like embeddings are basically floating point numbers. You can also say 0.1, 0.3, 0.3. So in this way, we'll create embeddings for each of the text chunk, and then we will combine all those embeddings, and we will build semantic index. And using this semantic index, we will build a knowledge base. So knowledge base is, you can say, vector database where we will store all the embeddings. So after splitting the extracted data into small text chunk and then creating embeddings for each of the text chunks, then we will save all those embeddings into a knowledge base or vector database. So we have different vector databases or vector stores available, which include ChromaDB, FAIS. FAIS stands for Facebook AI Similarity Search. We have ChromaDB as our vector database. So FAIS and ChromaDB are store the embeddings locally. Okay. So we have other vector databases as well, like Pinecone. So Pinecone store the embeddings in the cloud. Okay. So if we store the embeddings in the cloud, it has the advantage that anyone can access it. While here we are using FAIS as our vector database or vector store. So FAIS store the embeddings locally in our system, and ChromaDB also store the embeddings locally in our system. So I'm using FAIS over here. So after saving all those embeddings in our vector database, which is FAIS, so in the next step, when the user asks a question, we create embeddings for that question, and then we do a semantic search or similarity search. In the semantic search, what we do is, for the question that the user have asked, so we have converted that question into the embedding. So we try to find the relevant answers for that question from our knowledge base. So we try to find relevant answer for the question from our knowledge base. And we can say that we try to find the top 5 answers for the question that the user has asked from our knowledge base. And we rank those answers. Like this is the top one. The top answer will be the closest answer to the question that a user have asked. Then we have the second number of, in the second number, we have also the answer, which is the second most closest answer to the question that the user have asked. Then we have a third most closest answer to the question that a user have asked. So in this way, we can rank 4 to 5 results. You can set the K value, like how much results you want from your knowledge base, or how much answers you want from your knowledge base. So we can have 4 different answers. We can have 5 different. We can have only one answer from our knowledge base for the question that the user have asked. Then, for example, we have got 4 different answers for the question from the knowledge base. Then what we do is we pass the user question directly to our Google PaLM 2 model as well. And then we pass the answers, like 4 different answers we get for the question. We have got from our knowledge base to the Google PaLM 2 model as well. And Google PaLM 2 model, what it does is it generates a natural response for the question that user have asked. So we pass all the top 4 answers to the Google PaLM 2 model, and Google PaLM 2 model generates a natural response for the question that the user has asked. So this is the architecture. Let's move towards the code part. Before we go ahead, let me show you how you can get your own Google PaLM API key. So Google PaLM API key is available under Google's Maker Suite. So you just need to go to the website developers.generativeai.google, and then you just need to sign in first. Okay, you can just sign in with your email over here. So if you haven't created your account, you can just create your account over here. So now I will just go to Maker Suite over here. Okay. So you need to request for the access of the API key. So I have already requested for the access of the API key, and I have been granted the access to the API key within 6 to 7 hours. So I will just create an API key. So I've already generated many API keys over here. So I will just copy one of them, and I will be using this API key. Okay, so this is very simple. So let's move towards the code part. So over here, you can see now I have just created a new project in my PyCharm over here. Let me just navigate first. So over here, now you can see that I have created a new project in PyCharm Community Edition. So I think it's visible on your screens. So you can see that I've just created a new project, recording chat multi PDF farm 2. This is the name of the project. You can write any name. So first of all, I will just go over here in the settings, install all the required packages which are required in this project. And I will just go over here, Python interpreter. And I will just go over here and install. I will just install Phi CPU. This is Phi is used as our vector database. And then I will just install LangChain. Install package, Google-generative AI. The third package which I have installed. Along with this, I require PDF2 so that we can load the PDF file and extract the data from those PDF files. So I've just installed all these packages. These packages are getting installed. You can see over here. So this will take few seconds more, then all these packages will be installed. Meanwhile, I'll just write script.py and let's start writing down the code. Okay, so first of all, as we will be creating a Streamlit application, so I will just start over here, import Streamlit. Okay, I have not installed the Streamlit package, so this is a merged package. I will just go to settings. Okay, I will just write Streamlit install. Okay, so this package will be getting installed, and then I will just write import Streamlit as st. Then I will just write from PDF2 import PDF reader. Then from LangChain dot text editor, I will split the text into small chunks. I told you that we cannot pass the extracted data directly to the Google PaLM 2 model because of the input character limit. Or recursive character text letter. Okay, and then I will just import Google.generative AI info as. We are just importing the Google PaLM model over here. Then I will just basically we will create embeddings for each of the text chunk, and Google PaLM API comes with its own embedding model as well. So we'll download the embeddings from Google PaLM embedding model. So I will just write from LangChain.embeddings import Google PaLM embeddings. Okay, and from I will just now import the Google PaLM order. So I will just write from LangChain.LLMs import Google PaLM. And I will just write from LangChain.vectors towards import files. So files is being our vector database. Then from LangChain.chains, I will import conversational retrieval chain. So we will be using conversation retrieval chain. Conversation retrieval chain comes with a comes with a memory component as well. So we can keep track of the conversation. So conversation retrieval chain is being built on retrieval QA chain. So conversation retrieval chains comes with a memory component, so we can keep track of our conversation history. Okay, so I will just add a memory component as well. From LangChain.memory import conversation buffer. Yeah. So now what I will just write over here, import OS, and then I will just write os.environment. Then over here, I will just write my Google API key over here. Google API key, which I would write over here. I already told you how you can generate your own API key. So You can just have your own API key. Over here, I will just write my own API key. So let me just add that. So this is my own Google PaLM API key. So first of all, I will just go below down from here and just create a function define main. Okay. So now I will just first write the title of our Streamlit app. For this, I will just write st.page.config. Okay, and the title of our Streamlit app will be chat with multiple PDFs, and the heading of our, so this will be appear in my above the bar, like this will appear chat with multiple PDFs. So let me show you let me just add the header as well, then I'll show you chat with multiple PDFs. And let me add an icon over here as well. We can also write if dash is equal to a. So let's run this. So I will just open this. Okay, currently the package is getting installed, so it will give an error. Let's write further code, and then as this package gets installed, then we'll run it. So first, what we want is we'll just create a sidebar over here with st.sidebar. So in the sidebar, I will just create title by the name settings over there. And then I will just add a subheader over there as well. Upload your documents. Go to your documents over here. And then I will just add pdf.docs st.find-uploader, and I will just write over here, upload your PDF files, and click on the process. Okay, so make it accept multiple files. I will just add accept multiple files is equal to true. And then I will just add a button. So if the user press the and add simply add button. Okay. Okay, so let's run this Streamlit application and see on this. Let's run this Streamlit app and see how does it look for likes for now. So let me just navigate my screen towards it. Currently it's running. Let's see. Okay, so st.page. So this is the error. Let's solve this out first. So here, in here, I'm just getting this error. Here we have set dash. So let's see. We just don't need to read on the script, we just need to refresh it. Okay, so now you can see that this is my title, chat with multiple PDFs. So here we have this chat with multiple PDF as our header. Okay, and over here you can see that in the sidebar I have settings, upload my documents. So if the user clicks over here, he can upload multiple PDF files. For example, let's upload some more PDF files. This is the second, and let's upload the third one. And here the user can click on the process button. Currently, nothing is happening because we have not added any action for this button. So for now, it looks fine, and as well as it looks good as well. So now let's go ahead further and let's write down the rest of the code. So first of all, what we need to do is we need to extract the data from those PDF files. Okay, so now what I can do is I will just create a function get PDF text. So we just need to extract the data from those PDF files and just create text over here. But I'm going to just go through each of the PDF files and then we will read the data from them. So I will just write PDF dash reader is equal to PDF reader. So I will just read the data from each of these PDF files and I will just write for page in PDF dash reader dot pages. Then what we'll go through each page of the PDF file. Then I will just write page dot extract dash text, extract the text from this PDF files, and this will return us the text. So for now, it's good. So after extracting the data from those PDF files, next what we need to do is we need to split the data into small chunks. So this is our target, to split the data into small number of chunks. So let me show you the architecture again as well. So after extracting the data from those PDF files, we need to split the data into small chunks, and then we need to create embeddings for these text chunks, and then we will create a knowledge base or vector database. So next what we can do over here is, so let's first try this. So if the user clicks on the process button, so we will just add st.spinner here. It will just write processing. And then over here, I will just call this. So first we write over here. Okay. So I will just get PDF text and PDF dash docs. And from here, we'll get the raw dash text. So now let's create another function to split the data into small text chunks. So I will just write get text chunks over here. And the input will be the text which we have extracted from the PDF files. So I will just write text dash splitter is equal to recursive character text splitter, and the chunk size will be 1000, and we will have a chunk overlap of 20 characters. So there will be maximum 1000 characters in each of the text chunk, and we will just write text dash splitter dot dash text, and the input will be the text, and this will return us chunks from here. Now I will just go over here and just call this function below as well. So the input over here will be the raw text which we have got, and over here we will have the output, the text chunks. So that's look good. So next was after splitting the data into small text chunks, we need to create embeddings for each of the text chunks. So I will just write over here, define get vector store. So we will create embeddings for each of the text chunks, and then we will save those embeddings into one knowledge base. So the input will be the text chunks over here, and we will be using Google PaLM embeddings over here. So we will download the embeddings from Google PaLM, and then I will just create a vector store over here. Okay, so the vector store will using files as our vector store, and I will just write from dash text, and the text chunks will be passed as the input. We will create embeddings for each of the text chunks, and this will return vector store. So we are creating embeddings for each of the text chunk, and then we are just creating a knowledge base. So what we are doing is that we are creating embeddings for each of the text chunk, and then we are just building a knowledge base over here. Okay, so good for now. Now we will just create a conversation string, so that we take the user question, create embeddings for that question, and then we'll just try to find the answer for that question in our knowledge base, and then we'll just rank those answers. So I will just write get conversational chain. Here the input will be the vector store. Okay. So I will just write Google for model I'm using, and the memory is equal to conversation buffer memory, and the memory key will be the chat history over here, and we'll just get the returning messages as well. True. And then we have the conversation chain setup over here, the conversational retrieval chain from dash LLM. Input will be the platform model, and the retriever will be the vector stored as retriever. Okay, and here we have the memory. Okay, so that's the word, and then this will return us the conversation. This return us the conversation chain. Okay, so conversation retrieval chain is built on retrieval QA chain, but it provides a memory component as well. So which was missing in the retrieval QA chain. Okay, so I will just call this. Okay, I have not called this as well. So what I will do is get vector store, and the input will be the text chunks over here. And from here, I will just get the vector store, and then I will just call the at conversation chain, and here will be the vector store over here. And over here, I will just get. So I will just create a session state over here. So in any case, so our information is not lost. So st.state conversation is equal to conversation chain. So that's the good for now. After all this processing is done, then we will have that sp.success. So we will have that done text appearing after all this is being done. So now what we can have this. So when the user asks a question, then what we can do over here is, but before going ahead, let's run this and see if it works fine or if there is any error. So for now, let's check this out. Yes, let's run this up for now. So let's upload the PDF file and let's upload only one PDF file to check if it works fine or is there any error. Wow, I think there is an issue. And let's see that. So there is an error. So let's see first. So there was an error over here as well. Got it. So other error which we are getting is so these spellings are not right. So let's run this again now. So there is another error. So let's run this again. So let's upload a PDF file over here. So it's processing, and let's see if it is done or if there is an error. So now it's done. It means that currently it's working fine. So let's complete the rest of our code. So here, let's add the option that user can ask a question. Here the user can input the question, user-question, st.text-input. Okay. Ask a question. Okay. So next, what we can do is, So if the user asks a question, that question currently let's write pass here. So what if the user asks a question? So what we can do is just create another function. Define user input. If the user asks a question, the user question input. So if the user asks a question, then the response will be st.session state. So conversation. The question. Then what we can do is I will just write conversation. So from here, what we write would be st dot. So we can just create another session state over here. State share history. So we will only take the chat history component from here. So what we can write over here is okay. So now what I can do is in an upgrade. So we'll want to get the index position as well. So I will just write st dot session state dot chat history. Okay, and I will just write over here. So st dot write I. Okay, so let's run this up and see how does it work. Okay. So one error which you can avoid is what we can do. Okay, let's call this user input and just pass user question over here. And what we can write over here is yes, conversation not in st or session that's there. That is not in st dot session that's there. Okay, so that's the work. Let's copy this any case. So let's run this up now and see if it works fine or if there is an error. So we can fix it. Currently, we'll just look with one PDF file and later we will just go with multiple. Okay, and I will just ask a question, region, qualification. So let's see what we get from here. Okay, so now you can see I've just asked Rachel qualification and Rachel Green has a PhD in English. Okay, PhD from University of Learners at Urbana Campaign. So experience. So here we have Rachel Green experience. Okay, that's the word. Rachel Green. Rachel Green. This. So now you can see that we can track previous conversation chat history as well. So that's good. Yes, this is Rachel Green resume as well. So what we can do, one thing further is just comment this out here. Just remove this. Zero. Then we can just write st.write. Over here, this will be the one message. So here we will not get any reminder. So if you just see this over here, on even numbers, we have the question, and on odd numbers, we always get the response. Okay. So then in our numbers like 0, 2, 4, we have the question. And on odd numbers, we have the results response. Okay. So what we can do for this is, message 10. That's on odd number, we have the bot response. So we can just okay. Let's run this again. Let's upload multiple PDF files. Now let's just first upload one PDF file and see if it's working fine. So this is my human Rachel Green calculation, and here I'm just getting one PhD in English. Okay, let's look. Okay, so let's start with multiple PDFs from here. So now I will just upload multiple PDF files from my system. Let's upload this. So I will just go with these two PDF files and let's click on process from here. So this might take few seconds more. The processing is being done. You can see the message, and let's ask here the V7 is used for. This is the first question which I am asking. Viola V7 is used for object detection. Okay, Viola V7 is trained on. I'm just asking Viola V7 is trained on which data set. Viola V7 is trained on the COCO data set. Okay, Rachel Green education. See another question which I am asking. What is Rachel Green education? Rachel Green went to Butler University MBA in English and Communication. Okay, Rachel Green qualification, PhD in English. Okay, Rachel Green experience. Okay, so here's experience coming all this. YOLO 7 outperforms which LV7 perform all known object detectors in both accuracy and speed. So here you can see that we have created a chatbot to chat with multiple PDF files using the power of LangChain and Google PaLM model. So that's all from this tutorial. Thank you for watching.